Jeversen, and also for the people. Can we have the next presentation? So we now are to look at the freight market and the impact analysis by Andreas Lischke from DLR. Oh, one back. And Fernando Liesa is joining us now from home. I hope it will work. Because we are doing now a presentation between DLR, Andreas Lischke, and Fernando Liesa, who is the Secretary General of ALICE. And yeah, I would like to have him now in the meeting, so that we can see him and that we can hear him, and then Andreas and Fernando can do this presentation. Obviously, we have a technical problem. Then I would say you start, and then we hope that we can solve the technical problem. Okay. When we need really Fernando. Sorry about this.
Thank you, Ben. I hope with you. Now I want to ask you to pay attention to our part of the project. We investigate to map and quantify the load in the European Union and try to find out what is the potential for these configurable trucks in the EU. And at first, I want to introduce to you my first slide, but now it's not on the screen. Here you can see the forecast, the official forecast from the European Union. We have rebuilt or mirrored it in our freight macroscopic modeling, and you can see the increase in the model splits, and we have an increase of the whole of approximately 50% of the freight transport between these 2 years, and the road will increase by 57%, rail by 38%, and inland waterways by 15%. So, and this was our baseline, and now we go to one as the first step. In other presentation was also told we have collected a lot of use cases coming from users, from practitioners, from logistic companies, from shippers, and the core idea behind was to get more information from the users and their requirements. And this, in the next step, we sorry. No, give. Doch. No, I'm lost. Okay, so I continue without the slide. The second step was we want to show you the impact by a freight modeling, and so we decided to have compared to the baseline by 3 scenarios, and I want to introduce you to the scenarios. And the final step, this is what Fernando Liesa will present. We try to bridge to the future logistics and the physical internet application, and want to show how does it fit to these new developments. This slide is quite complicated, and so we have make a poster here on the left-hand side for me, and you can see there more details. But in general, we have on the left-hand side the improvements we can see and using different prime candidates. These prime candidates are several configurable vehicles coming from the former Falcon project we used in this interviews. And on the top you can see what we have considered. These are different euro and CO2 values, and we also considered the consolidation factor. And on the right you see we scale the consolidation factor what does it mean in this to use configurable trucks. And here we clustered this a little bit. On the left-hand side, we see the cluster of, so can say, low improvements, 2 to 10% energy savings. For instance, here, prime candidate 1.3, that's the standard semi-trailer and tractor combination, to a dolly combination, so similar to EMS1. Then we clustered the second area with, for instance, this prime candidate 2.2 to 4.5, makes us longer without any dolly. And the third cluster was this from standard tractor semi-trailer combination to a PC1, as a prime candidate 6.1, and this is an EMS2 configuration. And you can see the different consolidation factors and the different savings we have gained in this using this. In the middle, you can see some special cases. Here we can consider that there is a high increase on euro per ton kilometers and euro per tour, but a low increase by CO2. And these are very special cases due to these are milk runs with several collecting points or distribution points. We have summarized all these use cases by doing here this overview. 53% of our interviewees give us feedback what are their prime candidates to use for their logistic transports. And we can see 11.7% are preferred such an EMS2 configuration. But we have also to consider on this top 6, the last one, that 10% of our interview partners said to us that they want to stay with a classical tractor-trailer combination. Then we tried to summarize all these results from these 32 use cases, and you can see that we find out average savings, for instance, in euro per ton kilometer and cost per tour, and also in CO2 per tour. But we have also to consider, due to the limited cases, that we cannot rebuild the reality as a full in this small cases, and we have a broad standard deviation. This is here to be seen in the parentheses. Now coming to, I will come to the second step we have addressed. What are the premises for the sustainable use of the EMS1 or EMS2? And first of all, we want to recommend that these trucks should more or less address the right segments. And we identified the segments based on the Eurostat statistics. And you can see palletized goods and other cargo not elsewhere specified are the potentials with a high transport ton kilometer with long distances. And this is what we have to be seen as a target market. And we also think that these are the groups that are growing also in the next 2 decades. Another point is from our premises, we should try to reduce or limit the reverse modal shift from rail or inland waterway back to road. We have seen in our modeling, it is a combination that the efficiency gain in one transport mode leads to more transport in this transport mode, and the other transport modes will be reduced. And we think that this should be done at first on a company level, and we should try to embed in the strategies of the companies how wanted to reduce the CO2 emissions in their transport, and this should be done, for instance, by this new EMS1, EMS2. Now I came to the results of our scenarios, and at first we have seen here this as a baseline increase in road mileage between 2010 and 2014 by 61%, and on the right-hand side the bar diagram shows you how will come the EMS1 and EMS2 into the market. We have as a first scenario only using EMS1, and we find out that about 7% of the mileage will be done then by EMS1. Then we have a second scenario with EMS1 and EMS2, then is 7.5 for EMS1 and 3.5 for EMS2. And then we exclude some selected goods that are more liquid or bulk, because we think we should, if we address these core markets I have shown in the slide before, then the increase is a little bit limited for EMS1 and EMS2. But this is what our model has said to us what could be the real market for EMS1, EMS2 in 2040. The impact on model split was also a topic in our work, and we can see here the transport ton kilometers, and as I said, in the several scenarios, there's a decrease in road and inland waterways and an increase in road, but we think that is not significant, but we think that is an undesired effect. And so we recommend that the policy should look for for measures to generate a level playing field. And our idea to do so is here in this picture. We have selected here for the intermodal transport chain. On the right-hand side, you see such a hub or a gantry crane, a terminal. And then they go to a shipper 1, to a shipper 2, and go back to another terminal or to the same terminal with EMS1. And we see that this is you can have more efficiency of pre and post haulage on road, because these costs on pre and post haulage are at the moment high impact on the general cost of the intermodal transport. And that can be combined with a high efficiency of EMS as an enabler to zero emission heavy-duty vehicles. So to say, we can use for this transport chains also pure electric trucks with an electric dolly, and so we can have this level playing field and improve, for instance, the intermodal transport. Now I want to hand over to Fernando from Alice, and yeah, the floor is yours, Ali.
Hello, Fernando, do you hear us?
I can hear you very well indeed. Can you hear me?
Yes, we can hear you. We only have an echo. Maybe we can solve the echo. And I will click the slide if you say so.
Could I share my slides, or do you have the slides yourself?
I have the slides, and I will click as you say so.
Okay, that's perfect. So then, thank you very much. I'm really sorry not for being with you today, but there were some issues here, and I was in the safe side and decided not to join. And really looking forward to this session and sharing this after 4 years of work with the AEROFLEX, and thanks to all the partnership. So then, if you go to the next slide. Just for those of you that you don't know Alice, Alice is the European leading companies and experts in logistics and supply chain. In the previous slide, you could see the number of companies and the type of companies representing different types of logistics stakeholders in our network. And what we do is really develop new concepts, knowledge management, and collaboration opportunities, and particularly following up research and innovation projects as AEROFLEX, and looking how this can contribute to our roadmaps implementation. And if we go to the next slide, we can see here our roadmaps. Indeed, we share our roadmap towards zero emission logistics at the end of 2019, just the day before the Green Deal was published, and there we identified 5 main areas of intervention, and 2 of them that are really linked to the vehicles and development of technologies for greening the vehicles, but also using zero and renewable energies. But there were other 3 that were really more looking into the freight transport and logistics. And here I already have the first conclusion is, as we have seen today in the AEROFLEX project, really going into these logistics efficiencies, we can really achieve reducing costs, but those costs can be used to really use more advanced technologies, particularly zero emissions. So then there is a lot of synergies that we can find between these more logistics-driven opportunities with the more vehicle logistics opportunities, and working with them together, then we can reach to a more affordable transition towards the zero emissions logistics, and particularly following some of the physical internal principles that AEROFLEX was showing today with the cargo transshipment and also with the puzzle software. So then going to the next slide. And here it's a question also that indeed the answer to the market uptake, it's also coming hand in hand with freight transport and logistics. I think AEROFLEX managed to deliver quite outstanding technologies, proven technologies, but they still need to find the way to the market. And here is we see still that transportation is not yet efficient, because sometimes the cost of inefficiency is less than the cost of transition. So companies still want to keep inefficient. But this will not last a lot. We see a lot of companies also looking into carbon reductions. And when we are looking into this process, we really think logistics efficiency will be more and more in the agenda, or more needed to really make the transition affordable. Now, if we go to my last slide, with the concrete aspects, I think it's very important that out of these projects like AEROFLEX, we really engage with freight transport and logistics companies to test the technologies in operations, because sometimes you learn from doing that, or you can even find shortcuts that could make the technology easier, or maybe you don't need so advanced technology to solve the actual problems. As Andreas was really sharing with us, I think a learning is that we need to have more focus on palletized goods in intra-European road flows, and they're going in more granularity. Which segments are the most inefficient, so then we can work with. And I think Andreas and his team made a very good job, but I think we also need to go more in detail with sectors, with segments are the ones that could be more suitable for all these technologies in the developing AEROFLEX. Then I think it's also important that the conclusions extracted from a general point of view are also linked to the baseline, and this may vary from region to region, because there are regions in Europe where there are no intermodal solutions or rail solutions. So for those ones, it's impossible that European modular systems has an impact on rail, because there are not actual goods flowing on rail yet. And also, it's important to understand when and where these technologies are going to have a higher impact and not so side effects. And then the other point is that looking into the future, and as it was said today, more and more these modular systems need to be combined with zero emission technologies, and the efficiency gains can really be used to support transition of the assets and trying to address these gaps we see when we are looking into zero emissions technologies, and total cost of ownership still very far from being competitive with current technologies. And this is, we have an opportunity in the review of the weight and dimensions directive probably next year. And then at the end, my last one is that we need to work on concrete use cases for which European modular systems can truly integrate it in the intermodal chain. I think it was a very good presentation from Eric Lambert before. And then also, I think the comment made by Steve Phillips on source CCP, it's very important. So it's key to engage with all the transportation modes. And I think the framework of these research and innovation projects are really good arenas to really have these exchanges, learning, and find the proper cases for these technologies and looking for what we want to achieve. That is really moving to the decarbonization of freight transport and logistics. And that's all on my side. Thank you very much.
Thank you very much too, Alex. I think that was a very good summary you gave of your reflection on the project, and I'm really delighted to hear this. And we see also that there's still enough to do in the near future. We see you back in the panel discussion later, I guess. So stay online and we continue. So thank you very much so far, and we see you later.
Thank you, everybody.
Yep.
See you later.
Yo. Thank you, Andreas, for also the nice view of the EMS market implementation and what are the consequences. I allow one question out of the group, and I'm looking at the time, we really have to push further. One question is allowed. No questions, then I would say thank you very much, and we will continue. We continue with Giuspeppe Cordua from Case New Holland, IVECO, who is expert in the passive safety simulation technology, and Ron Schindler from Chalmers, who also did a lot of work on the accidentology study. Later, we will call in Michel van Ratingen from EuroNCAP, and we will invite Erik Dahlberg from Scania to join us on the floor. There you are. So you are now in my neighborhood. You cannot walk away anymore. So, but first, let's start. And yeah, okido.
Thank you. Okay. So glad to be in front of you today. Me and Ron, we will talk about work package 5. And the work we have done about the innovative front-end design for more safety. Let's start with a summary slide in which we will describe very quickly what was the aim of our work, the objective, and the approach we have used. So the aim was to develop a safer front-end for the new generation of long-haulage truck in order to reduce the injuries on the roads and the fatalities, and contribute in the zero vision targets. So up to 50% fewer injuries and fatalities as short-term benefit, and zero fatalities by 2050 as long-term benefit. In order to do that, we had as objective to evaluate the critical safety factors and the causes of the accident. Then we identified, we did a conceptual study in order to identify some passive safety solution to mitigate the effect of the accidents. And we also did a study, studied about the installation of some ADAS, so active safety system, in order to address the most relevant accident scenarios. Then we evaluated the benefits of these measures, and we provided a recommendation for updating current regulations. In order to do that, we split our work in 5 tasks. One was related to the accidentology analysis, the second one about the evaluation of the accident scenarios, so the elaboration of the data and the reconstruction of the scenarios. Then we defined this active and passive safety solution, and in the last task we defined this benefit analysis. Ron?
Yes, so yeah, the first step we did in our analysis was we needed to understand what is the current situation, what are we faced with, what are we looking at. And in order to understand that, we performed a 3-level analysis. We looked at 3 different levels of databases. We looked at an in-depth crash database called GDAS. We looked at national crash databases for Sweden, Spain, and Italy, which is data that is collected by the police. And we looked at European crash data from the CARE database to also get an understanding for the general situation in Europe. So the first thing from the results that we want to have a quick look at today is to look at who is injured in crashes that involve heavy trucks. And in the graph that you can see, we can see that most of the time it is car occupants that are injured in these crashes, whereas the truck drivers themselves, they are injured as well, but not as often as car drivers. And then especially vulnerable road users have a specific role here because they cannot rely on a protective shell around them. So even in low-speed crashes, the likelihood for severe injuries is very high. When these crashes occur with heavy trucks, typically they occur in dry and clear weather conditions. So we have a dry road, the sun is shining. Most of the time, those crashes occur on non-highway roads in rural areas from the crash databases. So in general, we don't see any trends for specific weather patterns that would influence the crash situation. Then from the analysis, we have identified three main situations that are really critical from the data that we see. The first situation are rear-end crashes. So rear-end crashes both with other trucks, but also with cars. They are the single largest group of accidents that happen with trucks. So this is the most common crash type with heavy goods vehicles. But we also wanted to put a focus on vulnerable road users. And there we identified right turn maneuvers of the trucks with a cyclist riding in parallel and with pedestrians crossing in front of the trucks as the most common crash scenarios. And then one thing we have been talking a lot about today are the EMS1 and EMS2 units, which are currently not allowed on most European roads. But we wanted to have a look at if there's a safety impact of those longer and heavier vehicles. In Sweden, those, not all of them, but the EMS1 vehicles, they are already allowed on the roads. So we had a look at the Swedish crash data, and we did a grouping between what we call the medium trucks, so that is what we have nowadays as a weight restriction more or less, and compared those with heavy trucks. So you want to compare the orange curve with the gray curve in that graph. And when we look at the crash risk, so the number of crashes those trucks have per billion kilometers traveled, we can see that the bigger, heavier, and longer trucks are actually much more safer. So they're involved in less crashes than the typical trucks we see these days.
Okay. Yeah, let's start to explain what we did with this elongated front end. The elongated front end of the AEROFLEX truck gave us the possibility to introduce some passive safety feature in order to mitigate the effect of possible impact with the other road users. Starting from AEROFLEX truck versus VRU, we introduced some soft material in the front end. We analyzed also the effect of pedestrian-friendly windshield. And we introduced also some specific absorber in order to absorb energy when the truck goes in contact with the pedestrian. And all of this allowed an enhance in terms of protection versus VRUs. Concerning the AEROFLEX truck versus car scenario, also in this case, the elongated front end allowed us to put a protective structure in the front of the truck in order to subtract energy during the crash and mitigate the effect of the impact in the back of the passenger car. This measures reduced significantly the intrusions in the back of the car. And last, we analyzed also the scenario AEROFLEX truck versus truck. But given the huge amount of crash energy in this case that cannot be effectively absorbed, this protection is addressed to active safety measures. I will explain in the next slide. Yeah, As explained before, we deal also with the ADAS system. ADAS aimed to prevent or mitigate most of the common accident scenarios involving heavy vehicles, plus 16 ton, and other road users. Furthermore, ADAS provide enhanced protection also to the truck occupants, as explained before, not possible with passive safety measures. We virtually installed 3 ADAS systems, and we configured it and tested them on the AEROFLEX truck. And the result were obtained by simulation for a high number of scenarios and test case variant, confirming a significant reduction of accident occurrence using ADAS systems. Those results can be used also as reference for truck A, B, and blind spot European working groups. Ron?
Yes, so the 3 safety systems that Giuseppe has now introduced, we wanted to know how effective, how good are these systems when we implement them into actual trucks. So the last part of our work package was to do a benefit analysis. To do that benefit analysis, we used the dose response model. Basically, if you look at the left graph, what this model does is we have a crash distribution, which is the blue curve, which is a representation of how many crashes happen at certain collision speeds, for example. Then we combine this crash distribution with the red curve, which is the injury risk. So how likely is it that a certain injury is going to happen if a crash occurs at a certain speed? So when we combine these 2 information, we get the dashed line that you see in the left graph, which is the injury distribution. And if we calculate the area under that curve, we get a number of injuries. So we know there's, for example, 100 injuries that would happen in the current situation. If you look at the graph in the middle, that is one example from the actual crash data that we looked at. The solid black curve is the crash distribution, and then the red curve are different injury risk curves. The red curves are for passenger cars occupants, and the blue curves are for the truck occupants. And in that situation, for example, the truck occupants are not injured, so the injury zero is 0, which is why that curve is on the bottom. And then into this system, now we model the safety system. So simulations were performed of the safety systems, and now what we can do is we can shift the crash distribution based on how effective the systems are. So if we look into the graph on the right, you see the blue line, and that blue line represents how likely is a crash to occur if the truck is equipped with a specific safety system. And what that curve does is you see the solid black line, that is the original crash distribution. And now when we implement the system, we see, or we get the dashed line and the area that is highlighted in gray. So the implementation of the system reduces the crash distribution, and that overall will reduce the injuries in the end. And we have performed that analysis both on GDAS data, so on a very detailed microscopic level, but we have also scaled the results that we obtained to a European level, so we get an understanding of how the situation looks in Europe. So now on this slide, we want to have a look at the 3 systems that we've seen before. All of these systems have been tested for different layouts and different sensors, and now I only want to present the best results, so the best performing systems, so to say. So what is the maximum potential benefit that we can see from these systems? So to start off with the AEB system, so the typical scenario that system addresses are rear-end crashes, and when we implement that system into trucks, we see that we can avoid about 85% of the crashes that we see in current crash databases. And now, if we look at the fatalities, we can see that for the truck drivers, we can reduce the number of fatalities by about 70%. And also for the crash opponents, so for car occupants, for other truck drivers, we can also reduce the fatalities of almost up to 70%. Then the second situation that we looked at were the right turning maneuvers with the cyclist going in parallel with the side guard warning system. And here we can avoid even up to 93% of the crashes that we see in current crash databases and up to 94–95% of fatalities. We don't have any graphs here for the truck occupants because in those situations they're typically not injured, but for the cyclists and also pedestrians in those situations, these situations are very critical. And then the last system was the lane support system. So that is a system that supports lane change maneuvers, both with other vehicles, but also with cyclists, for example. And with that system, we see a reduction in crashes of about 53%. And for the fatalities, we are looking at about 29% of fatalities that we can avoid. That system seems like it addresses the more minor cases, so the number of fatalities that we can reduce is not as high as compared to the other situations, for example. So all these analysis and all these results I've shown now should be taken with a little grain of salt, because there's a lot of limitations and assumptions that we had to take into account when we did this analysis. So these numbers that you've seen now, they represent an ideal state. That means we have an ideal sensor performance, we have 100% market penetration, so every truck out there is equipped with this system, and also 100% user acceptance, so the truck drivers don't turn the systems off, but actively use them. So in order to get to these numbers that we've shown, first of all, it's going to take a lot of time until these systems are implemented in a large part of the fleet. And we might never reach those numbers because there's sensor performance limitations and these kind of things. Then when we look at the injury risk curves, for example, that we use, the sample size that we have is really low. The GDAS database has thousands of cases in it, but if we compare that to more than 1 million crashes that are happening every year on European roads, the sample that we have and can use is very small. So that is quite a limitation for this analysis. And then last but not least, we could only perform this detailed analysis for the active safety systems. And in addition, the combination of the results from active safety systems and passive safety systems, so combining the benefits we get from both systems, that still is a significant hurdle at the moment. So that will need further research in the future so we can combine these effects we get and get a better understanding, better estimation of how good this integrated safety approach works.
Okay. So now we would like to highlight conclusion and opportunities. In summary, the combination of safety measures, such an elongated front-end design with specific passive and active safety system, provided an optimal protection in case of truck versus truck, truck versus car, and truck versus VRU accident scenarios. The elongated front-end, of course, have some influence on existing regulation that needs to be discussed, amended, like ECE 29 about the cap strength or ECE 93 about the front underrun protective devices. And in the end, we would like also to support with our study the creation of a consumer assessment program. We call it EuroNCAP, similar to EuroNCAP for passenger cars, to motivate the introduction of this active and passive safety measure in trucks and reduce the overrepresentation in fatal crashes. That's all from.
Thank you very much, Giuseppe, and thank you, Ron. We welcome Michel van Ratingen, representing EuroNCAP. Welcome, Michel. Can you hear us?
Yes, I can hear you. Can you hear me?
Yes, we can hear you loud and clearly. And I also invite now Erik Dahlberg on the stage, who is from Scania and representing then the OEMs in Europe. Michiel, we have seen now the analysis of our studies with regard to the Accidentology and our proposal to go into a discussion or a dialogue to set up a kind of a EuroNCAP instead of a EuroNCAP. And you are invited to comment to this or to give your strategy. And I would like to give then Erik Dahlberg, representing the truck industry, also to comment on that, so that we can maybe have a kind of a mutual way forward, or we have a diverse way move forward. So, Michel, you are invited.
Yeah, thank you, Ben, and good afternoon, everyone. It's a pleasure to be here in your session, even though I'm not there physically. It's certainly appreciated to be able to comment on the results. So first of all, congratulations with the very good work that has been done in the project. These show that delivering real improvements in truck safety is still possible with passive and active safety measures, and certainly supports also our view that Vision Zero is also achievable in trucking. When I look at what you have done, it's quite similar to the study that we have done in the last 18 months at EuroNCAP, as far as studying accidents with heavy goods vehicles in Europe. We also included markets like the UK and France and Italy in this mix, and try to estimate the benefits of various measures, which includes things like AEB, as you mentioned, lane support and so on, but also things like occupant monitoring systems or driver monitoring systems, etc., etc. So more the newer generation of systems that we already see appearing in passenger cars. So our conclusion from our study, at least, is really in line with what you conclude, which is that by faster deployment of safety technology and promoting higher performance levels, we can actually still contribute to a significant casualty reduction on the real world. The new truck assessment program, as you mentioned, that would go over and beyond, let's say, the type approval requirements, could be a good catalyst for faster adoption. However, there must be a few things to note here, which I can only mention from my experience at EuroNCAP. So maybe the first thing that I noticed is that the trucks come in all shapes and sizes and are used for different purposes. A safety scheme should really take this into account if it's usable for the end user. So in particular, the differentiation between, let's say, urban use of trucks versus long-haul use of trucks, they are really involved in different kind of crashes in the real world, and that should be kind of reflected in the safety assessment that you do. The second point that I would like to raise is that the market for heavy trucks is very differently operating than the consumer passenger car market. So what works for consumers is not necessarily going to work for trucks. We really would need the support of fleet operators, of road authorities and cities to help us really create demand of safer trucks. We know that fleet operators are not inclined to put additional safety technology on trucks if they don't, if that means higher costs for operating the trucks. And so we really need to have a paradigm shift here at the side of the fleet operators and the road authorities to actually see the overall benefits of adding safety to trucks. The last point is that sort of local initiatives, for instance, Transport for London has their own lorry scheme. They are, of course, great, but if we really want to motivate the industry to put more safety on trucks, then we should make sure that the safety system that we introduce, whether it's called a TAP or a truck safety scheme, should be European-wide applicable. So not just for a local market, but it should be really applicable to all member states of the European Union. And that would actually mean that truck designs can really be adapted for a good score into what the Euro TAP would be. So that was kind of my first reaction to the presentation. I really would like to thank the AEROFLEX team for showcasing again the importance of a new safety technology, specifically the active safety technology on trucks. And maybe last point is that we would really welcome a follow-up meeting with the team to further discuss their ideas about an NCAP program and how we can maybe join forces on making that a reality. So thanks again for the invitation.
Much, Michiel, and yeah, Erik, you're representing the truck industry. I think you have heard Michiel's comment, and yes, I believe that it's really also in your line of thinking.
Well, absolutely. Just first to comment on Giuseppe and Ron's presentation, which was very good. And I think what you pointed out there, and it relates also to the other question, the active systems coming in, how they change the accidentology, so to say, how statistics can get old. I mean, we already with the first general safety regulation got the AEB and the LDW, which already now is affecting the crash pattern, so to say. And now with the second general safety regulation, we get the requirement for the blind spot information system, for the bicycles detection, and the moving off for the pedestrian protection, and the direct vision regulation. And any future regulations should take into consideration and evaluate what is actually happening with the statistics, because it will have a great impact and reduce the number of accidents. And going over to EuroNCAP then, I think there are two things I would like to comment. The first thing you already touched, it's that our customers are not the same as consumers. So in order for a EuroNCAP to be successful, you need to find what are the difference needed to address our customers, of course. The second thing, which I think is even more important to consider with the EuroNCAP, is that if I exemplify with my own company, we deliver around about 100,000 trucks a year. 60,000 out of them have different unique specifications. So there is no way, I mean, we deliver less than 2 vehicles per model, if you like, a year. So there is no way that we can assess trucks per model. We need to find some kind of individual evaluation that can address the city safety, for instance, per vehicle. If that is done, and if we take care about the different business model and the different customer behavior compared to passenger cars, there might be a chance that it becomes successful.
Thank you very much. May I thank you all, Michiel, Eric, Ron, and Giuseppe. I think a lot of work has gone into this project and the project. And yes, I'm looking forward to, Michiel, that we have a follow-up conversation with the parties involved, and also with the legislative part, that we see how can we move forward in the future, and to see how can we incorporate these innovations in our truck designs in the future. So may I thank you all, and yeah, see you soon, Michiel, and yeah, thank you too. And yeah, this brings us to the end of this part. Unfortunately, well, we have stolen your coffee break, so we continue. Otherwise, we are not ready on time. But since I'm a flexible man, I allow you 10 minutes break. Be then really back for coffee, because some people have to leave on time, and it would be a shame if we then have to cut in a rude way. So please, 10 minutes coffee break, and then, yeah, we see you back. Thank you very much. We now start with our last part of the afternoon. We will first look into maybe one of the most important topics of this afternoon or the whole day. It's easy to develop technologies. It is easy to invent new innovations. But what is more important is how can we bring it into practice? How can we implement all these innovations? And to guide this process, IDIADA have guided us in the project in setting up a book of recommendations. Really look at the innovations and really look at the way how we could have an implementation of them. For that, we have at this moment Oriol Flix on the stage and Xavier Font, who are the experts when it is about homologation issues. And after their presentation, we will follow with the second presentation about intelligent access policies. as the second part of the book of recommendations, followed then immediately with our panel discussion. So please, thank you very much.
So thank you, Ben, for the introduction. My name is Oriol Flix. I'm a homologation engineer from IDIADA. And as Ben said, after seeing all the innovations that our partners have been explaining during the whole day, so during this morning and this afternoon, we took into account these innovations, and we, as a work in package 7, the purpose of our work has been to develop a book of recommendations. Okay, that means that we have, first of all, did a gap between the innovations that we are proposing and the current state of the art of the regulations. And after that, we are going to propose some changes and amendments to the current framework of the regulations in order to deploy these systems as soon as possible to the road. Okay? Not only on the vehicle type side, but also on the infrastructure side and the use of these innovations or these vehicles. So, okay. So in order to do so, we have divided the presentation into 2 main areas. So the first one, and it's quite important, but I will be brief, is the rulemaking procedure. So we have identified to who we will have to address with our recommendations in order to put in place. Okay, so basically we have 2 main policymakers or organizations that are the European Commission that will develop the technical guidelines, but also the administrative requirements. That means that they say when we have to put in place, also into the market, the safety features that we are developing. And after that, the United Nations, who is setting up the technical requirements, so the minimum performance that we have to fulfill with these safety aspects. And finally, we are going to enter to the recommendations that we have divided into main areas. The first one, we are going to go through each of the main working packages that we have developed and explain the most important ones that we should amend. And after that, the last package that is involving all the new technologies and the main regulations that will affect all the technologies that we are going to explain. So in order to not repeat in the first package. So okay, let's going to start with the rulemaking procedure. So when we are talking about the European Commission, in this case, we have identified 2 main areas that we have to address with. The first one, among these 53 departments and the executive agencies, but maybe the most important for the AEROFLEX project, is DG Klima, the one related to the carbonization and the reduction of the fuel consumption and CO2 emissions. So this one is quite important for us because the AEROFLEX project is aiming to reduce that. So we are going to address them. And after that, a whole package that includes some different groups that are related to mobility, connected and automated systems, the ones that are showed in the right side, DG RTD for the research, DG Grow for industrialization, DG Connect for connectivity, and DG Move for mobility. After that, on the other side, we have the United Nations groups. So here what is important is to understand that we have to focus on the WBP29, that it is the World Forum for Harmonization of the Vehicle Regulations. And inside of this World Forum, we have 6 expert groups. Okay, so GRBP about noise and tires, GRE for lighting, GRPE for emissions, GRBA for connected and automated vehicles, quite important nowadays, and also the last 2 for general safety and passive safety. Okay, now we are going to enter to the second part of the recommendations. So here, first of all, we are going to explain 3 main regulations that should be amended or changed regarding the aerodynamic features that we have developed inside of the project. So the first one is related to regulation number 73 for lateral protection devices. So in these cases, we have these side skirts that can be movable on the vehicle. And in this case, we have found that we have to put some requirements in order to not leave empty spaces between the wheels in order to fulfill the requirements that are inside of the regulation. So it's important to cover all the areas between the vehicle in order to avoid that there are underrun pedestrians or other vehicles. After that, we are going to focus on regulation 13 about braking provisions. So the use of these side skirts will provoke a worse brake performance. So when we are going downhills, for example, with prolongated brakings, the brake performance will be worse because of the dissipation of the heat. So in this case, our proposal has been to test all the vehicles as a worst case with the side skirts in use position. And finally, for the aerodynamic features for the complete vehicle, we are going to focus also on Regulation 58 about rear and ram protection devices. And in this case, it's more related to set up requirements for these devices that are lower in height of 2 meters, okay? This is to obtain safety for vulnerable road users, but also for rear-end collisions with other vehicles. Also important, we have to combine some way the adjustable ride height of the trailer with these features that we are installing in the boat tail of the vehicle, okay? So as I said, Regulation 58 set up provisions for all these features that are lower than 2 meters. So in this case, if we have a trailer that can adjust the height, then we have to see how we will interact with these two systems. Okay, so now we are going to move to the smart loading units. In this case, as the innovations that we are proposing on the project do not affect directly inside of the road, so in use position of the vehicle, let's say, so it's more done in private areas. Mainly the vehicle type approvals or vehicle systems will not be affected in this case. But we have found that there is a regulation, quite new regulation regarding onboard waiting equipment that are systems that will be mandatory in the following years in Europe. So in this case, our recommendation is in line to align and have a possible combination between the onboard waiting systems and the systems that we have developed, such as puzzle or cargo volume detection. Now we are moving to the innovative front-end design for more safety. In this case, as our colleagues explained it before, what is more important mainly is the Regulation 29 regarding protection of the occupants of the commercial cab. So we have slightly changed the front-end design of the vehicle. So probably we will have to assess what happens with the collisions that we will have with other vehicles, so cars and trucks. And in this case, we will have to study the casualties of the new collisions that we will have with this front-end design, and if needed, to perform new tests or to develop new tests according to these new collisions. In the other side, we will have regulation number 93 for front and ram protection devices, but it's more related to the new materials, soft materials that we are going to introduce to the vehicle. So we will have to evaluate this new front-end design according to the materials and set up new requirements according to the possible collisions that we will have, and also with pedestrians and vulnerable road users, not only cars. So, of course, we all know that the safety is the sum of active safety and passive safety. So both are very important, and the coupling of these two, active safety and passive safety, will reach to the final safety of the road users. So regarding active safety, we have included some vulnerable road users provisions on Regulation 131. 131 is the regulation about automated braking system. No, yeah. And in this case, we had that this regulation only included collisions between vehicle to vehicle. So we have included some provisions to vehicle to pedestrian and vehicle to cyclist. Actually, this is being developed inside of the United Nations Task Force Group, so it's something that will be applied in the following years, but we can provide some recommendations because we already have some data on that. On the other side, we have new advice on Regulation 152 regarding blind spot systems. This right now covers also trucks and coaches, but we have included some provisions also for modular vehicle combinations, because modular vehicle combinations have more blind spots than a normal truck with a semi-trailer, for example, or so on. And finally, we are assessing ADA's informal group that has newly been created in GRBA. So it's a group that is developing all the new ADAS systems. So according to the data that we have obtained during the simulations, we are able to provide some data to them. On the other side, for the passive safety, as it has also been said on the last presentation, we are focusing more on future recommendations with EuroNCAP tests. So we will have, or we want to have something similar with what already is being done with passenger cars. And this is more related to front end of the cabin and of course with the frontal protection device. So now I'm going to give the floor to my colleague Xavier Font.
Thank you. Okay, so I will continue with the recommendations now for the remaining technology that has been developed for this project is the Advanced Energy Management Powertrain, which will affect principally the Regulation 79 for steering equipment, because it will need to be amended as to include the trailer in the trailer definitions, also the option of having a towing vehicle with a towed vehicle with towing capacity. In addition, it shall be ensured still that the swept area requirements by the rearmost outer edge of the different trailers in a combination is still fulfilled. On the other hand, we also have Regulation 13 related to braking provisions. It shall be amended, it is being amended actually, as to still comply with the requirements for time response for each individual trailer in a combination. So the same requirement of 0.4 seconds for time response of the trailer needs to be fulfilled for each trailer individually. And also some other requirements will need to be included for towing trailers. Okay. I would like to say as well that during the project, of course, the project started 4 years ago, but now in the latest supplement of this regulation, supplement 18 of the 11 series of amendments, which is entering into force at the end of this month, these requirements has already been included. Still in the Advanced Energy Management Powertrain, also another regulation which is affected is Regulation 55 related to coupled components. Even it's true that some of the modular vehicle combinations are already included in the annexes of the regulation. There are no specific requirements for those vehicles, and there are no definitions. Only dolly definition is included currently in the regulation, but still other options of this kind of trailers shall be included as towing center axle trailer, towing semi-trailer, or even link trailer. Okay. And related to electrical safety and electrical powertrain, of course, Regulation 100 will need to be addressed as to include in the scope of this regulation any kind of trailers. Not, electric trailers or the e-dolly, of course, they are not included currently in the regulation. They will need to be introduced because they are now equipping heavy, high voltage batteries and also other electrical components, so it is important to include them. And now, as an overall recommendations, okay, because they are affecting several of the technologies presented, we also need to explain or to present the recommendations for the maximum authorized weights and dimensions in International Traffic Directive, okay, and the latest amendments, which the Annex 1 of this directive will need to include combinations for modular vehicle combinations, basically by establishing limits on maximum authorized lengths and heights for these vehicles. And also some exemptions will need to be considered. As for the aerodynamic devices lengths, regarding the overall length of the whole combination, and also the need or not need of including the elongated caps out of the total length. In this connection, it is important that it will be necessary to review what is the contribution of the electric dolly to the requirements of weight borne by the driving axles of a vehicle combination, which must not be less than 25% of the total laden weight of the vehicle combination. But as the driven axles of the electric trailer are not always let's say, are not driven axles full-time, it shall be considered what is this contribution and how this requirement is still fulfilled. Still related to masses and dimensions, but now moving to the European regulation 2019-1922, it is important to include in the scope and in the definitions the dolly and the electric dolly, as well as other trailers with towing capacity. As these vehicles will still need to comply with mass of combination formula and also the maneuverability requirements. And related to aerodynamic devices, it is important to include safety and operational tests and requirements for these new devices, and the inclusion of the exemption on the length of these devices. And also related to elongated caps, which are protruding more than half a meter in the frontal extension, it needs to be evaluated if these caps need to include new exemptions as to take them out from the maximum length of the vehicle. And the last regulation that we have considered, and it is very important, is the regulation 2017-2400, also known as Vector regulation. So it is the CO2 emission and fuel consumption for heavy-duty vehicles. Related to advanced electrical management powertrain, it is important that this kind of vehicles are included, or of course trailers, but e-trailers are included in the calculation of CO2 emission and fuel consumption, especially taking into consideration that now they equip electrical components as the e-axles, as the batteries, and so on. So the coming amendment of this regulation will introduce some types of electric components as well. And further amendments will include the e-trailers. And related to aerodynamic devices, they shall also be included in the CO2 calculation methodologies, okay, as to be able to create vehicle combinations. And it will be necessary to include new solutions or new aerodynamic tests for testing the performance of these devices. In terms of aerodynamics, how would this should be addressed? We think that by means of percentage of air drag reduction, okay? How it can be done? It can be done or by comparing results between trailers fitted with and without these aero devices, or maybe by establishing standard values to each aero device and setting a percentage of air drag reduction or air drag improvement for each of those devices. Okay, so that's it. Thank you.
Thank you very much. A hell of a lot of work. What is the next step?
Next steps should be to present that to the relevant groups. Let's say.
The working groups to get it implemented.
Yeah, and to push a little bit them.
Okay.
What do you think?
The time frame?
That's more complicated, I think. So I think that it should be evaluated case per case in order to see what is more relevant and what is needed for the market, and also taking into account the cost benefit. Okay. So depending on that, I think that...
also, as different regulations are affected and different regulations are discussed in different working groups, it will have different timelines for each of them. So
good. Thank you very much. And I want to introduce Karel Kural from the University of Applied Sciencis, who is going to talk about intelligent access policies. After the access policies, we will start immediately with the panel discussion so that we can integrate the questions and also the topics which have came forward during the day. Karel, thank you very much.
Can I ask for the
remote? Yes, of course.
Thank you very much. And good afternoon. Okay, to start this part of the presentation, I would like to share with you the vision we had in AEROFLEX, where basically we have these three pillars of the vision on the 2030, which are also aligned with the vision, well, which the European Commission has, I would say. Well, first one is obviously the safety, where we believe that we will see more safe transport in both modes, for passenger transport, but also for the transport of goods. I think we will also see more and more zero-emission vehicles, which will be mainly operating in urban areas to, let's say, make the cities more clean and more livable. And last but not least, we will see, I would say, synchromodal transport, so not only multimodal, but I would say combination of all modes, where all the benefits will be combined at the right place and the right moment. This was the driver for our work in this part of the AEROFLEX project. And we identified the intelligent access policies as one of the enablers which can help us to get there. To give a little bit of a context, we see that we developed in AEROFLEX project many new technologies which are, well, the new front-end design, and we saw a great work on the distributed powertrains and the smart loading units and the aerodynamics. But in reality, what is happening is that we are facing the, I would say, legislative barrier, as we call it here, a mismatch. We see a lot of scattered policies which are happening on a local or municipal level. And when we talk about, let's say, the access of the vehicle to the infrastructure, the main I would say, obstacle is the Directive 9653, which sets the limits on the weight and on the length of the vehicle. And what it leads to is basically a polarization, because a vehicle nowadays is either granted to access the vehicle, let's say the infrastructure in a full size, or what happens is that it's rejected. And this is sort of oversimplification of the situation, which doesn't allow us to use the full potential of the infrastructure. Moreover, this legislation doesn't fit very well to the multi-articulated vehicles or EMS-like vehicles, because, well, I think you saw it today. These are completely new type of vehicles which may have different needs for the certification and the safety. So we believe that intelligent access policy may be a great enabler to facilitate the deployment of this new generation of vehicles. And this is what I would like to start talk about. So what is basically the intelligent access policy? There are many definitions, but the one which we respect in AEROFLEX is that it's a regulatory framework which is using the vehicle technology to ensure that we have a right vehicle at the right cargo, which operates on the right road at the right time. And the goal is obviously to secure the minimum impact on the environment, on the infrastructure, but also on the human health and the society. IAP in this context represents a national evolution of the regulatory framework, because we are using the digital solutions, and we basically ensure a matchmaking between the vehicle abilities and the infrastructure capabilities. That's, let's say, the essence of the work. If we look one step beyond, it is basically, it goes about the data exchange, and the data which are static and which are dynamic. Now, as I said, it goes about the matchmaking between the infrastructure and the vehicle. So both of these entities, you can imagine, have a static part, which in case of the infrastructure can be represented with a bridge capacity, lane width, or slope of the road. And as for the vehicle, we can see that from the perspective of the maneuverability of the vehicle, of the dynamic stability, on the emission class. And basically those two needs to match. On the top of it, we have also dynamic data, which can be represented by the actual loading condition of the vehicle, real-time position. We can have a look on the weather. And all these things together can somehow couple the vehicle and the infrastructure, and we can let's say, dynamically control the access of the vehicle to the infrastructure. While looking on this from the very high level and let's say taking a step back, we realize that sort of an infrastructure access policy or intelligent access policy is already operating or it's being already adopted in Australia. There we see that there is this triangle where you see that in the points you have the intelligent access policy service providers on the top. We have the transport operators, and we have the road agencies, which somehow works together as the main stakeholders. And in the middle of it is a facilitator. This facilitator is called Transport Certification Australia, which ensures that the data flow from all these entities go in the right directions and also represent sort of a trustee in this process. In Europe, we believe that it can operate in the very same way, but we believe that we also need to bring policymakers on the table, because this is something which should be considered. And obviously, each of these stakeholders have different needs and different benefits from participating in such a scheme. For the users, which are the logistic service providers or the fleet owners, for them, the great benefit is that they're going to have a better ability to plan their transport, and they can forecast and interact with the other transport modes in a better way. As for the planners and owners, the intelligent access policy can be a great tool to maintain and plan the maintenance of the infrastructure, as well as to monitor what is the current loading status for the infrastructure. Then we have here a telematic providers, which ensures basically the communication between the vehicle and the facilitator. For them, this can be a great new business case. And obviously, we're going to have also a policymakers, which needs to act in this process as a front runners to stimulate and start small, national, local pilots to basically learn by doing. And last but not least, the last cluster or the last stakeholder is the facilitator, which is seen crucial for such a process and which we currently do not have in Europe. So this is, I would say, the stakeholder which bundles all the stakeholders together and ensures that the IAP works in the same spirit like in Australia. What happened further on was that when we want to develop this vision further, we organized a number of interviews and quizzes and workshops to basically summarize this vision in this bulletin, which can be downloaded on the AEROFLEX website. And I think you who are participating here, you already get it with the registration. So this is where we basically validate the vision we have and where we develop it further beyond the AEROFLEX. Given the time, I would like to just pick up a number of findings which we have there, but well, more you can read here. As for the key success factors to adopt this framework, we believe that the IAP can be a great enabler towards the CO2 reduction, and we believe that it can also speed up the implementation of new technologies, which imposes, I would say, special needs or special requirements for the infrastructure, as, for example, using electrical or, let's say, zero-emission technology, or, for example, teleoperation. The second success factor is the data exchange, which needs to be, let's say, integral, and it needs to be done in a correct way. Otherwise, you risk that the data are flowing in a direction which shouldn't go, and this can be a great risk for the success of the IAP. As for the key insights, we believe that the IAP needs more attention and more awareness should be created, and this can be done by the webinars or dissemination through the European technological platforms, because it has the ability to enhance the logistic processes. Furthermore, we believe that one of the biggest challenges is in harmonization. We are having here 27 different jurisdictions, and therefore the approach should be bottom-up, meaning we're going to start in a small local national-based pilots, and we will try to develop this further and going, I would say, cross-border. The next insights are that the facilitator is having crucial role, and gaining the trust is essential in this way. And a facilitator needs to have, I would say, solid mandate in terms of this process, so he can control the framework. Talking about the next steps towards the deployment, well, the ultimate goal is the safe and seamless transport system, which is powered or enabled by IAP. And we have these, I would say, two success factors aligned. One is the facilitator, and the other is bundling the impact of the high-capacity transport with a new vehicle concept or technology. And then what we need to do is that we need to go stepwise. So first of all, we need to do the mapping of the stakeholder needs and the business case. That's already what we started in the AEROFLEX. We need to start with a small local national-based pilot and possibly initiate further research, which will enable to go big, to start on a cross-border and do the research on a European level. This is going to create the working groups in Europe on a higher level, which will support this cross-border transport. And this may eventually lead to a deployment of the framework and a revision of the legislation on the European and national level. And obviously, this will lead further to the deployment and implementation in the entire Europe. And our dream, our vision is that this would be very nice to happen somehow around year 2030. Now, this brings me to the end of the presentation, where I would like to hand it over to Ben and to the discussion panel, where we're gonna have some participants from CEDAR who are taking this idea of IAPs into their program, and as well as the air truck. Yeah, thanks.
Thank you very much, Karel. I put you under a little stress because, but you did it very well, and I think he owes a second applause. We are now going over to the panel discussion, and during the panel discussion we can exchange views and opinions. May I invite the panelists on the stage? Ewa, Aurora, Ignacio, Eric, Loes, where are you? There, okido. Thomas and Steve, can you be around us? Otherwise, it starts to be a little bit too crowded on the stage. Can I show in the monitor the slides that I know how to put where? Because then people at home know who is where. So, and in the meantime, I can welcome Fernando Liesa again. Hello, Fernando. I hope you hear us. I can welcome Raluca Marianne, I believe, there. I see. Then I see Sven. Hello, Sven. Sven Besecke from Volkswagen, Raluca Marianne from IRU, and I see Thomas Fabian from ACEA. Welcome all on board. I'm very happy that you are joining us, and I hope you were able to follow the discussions, the demonstrations. So I hope you had an enjoyable day. So may I ask, Iffet, you stay in the corner because you have to moderate. Then I would like to see Christian Brenneke. Where is he? If you go to the this side, then Ewa Spaczinska, you follow here, followed by Aurora. Because then the people at home see the screen that they know who is who. Then Ignacio Lafuente from IDIADA, thank you. Loes Aarts. And then Eric Lambert for CFL. And then we have 2 chairs for Thomas and Steve to join us. So you are welcome on the stage. We managed to have all people on board. I hope that people at home can follow us and can join the discussion panel. Yeah, I would say, Iffet, I stay here. If you need my support,
yes,
then
don't go away.
I don't leave.
Wow. Ladies and gentlemen, what an honor to be here. What an exciting day. Welcome to the AEROFLEX final event, panel discussion. Welcome our panelists. Welcome everybody. It has been an extremely exciting day. The whole day we have seen the field experience of our AEROFLEX demonstrators. we have seen the presentation of the innovations, the benefits to the society, but more, it was a hybrid event. So there were hundreds of people virtually joining, and then I have informed that people were joining from Japan, America, driving. Please drive safe, don't look, only listen, by the way. So, as it's the final event, I have no time, so I will not make it longer. But I would like to say, for 4 years, group of people from manufacturers, suppliers, research institutes work together. This is usual for a European project, but what was unique, what is unique for AEROFLEX is a very powerful sounding board, over 70 participants, which represent the legislations, authority, policymakers, and that is why we would like to finalize the day with such a large stakeholder group. So once again, welcome. Christian from ZDF, thank you, welcome. Eva, Aura from DG Move, welcome. Ignacio from IDIADA, Eric, CFL, Luis, welcome from the Ministry of Holland. And welcome to Thomas, Raluca, and Sven and Otto, yeah, and Luis, sorry. Fernando Liesa also welcome. So I will shoot the first question, as the time is limited. Let me shoot the first question, is we have seen so many of these innovations, and very pragmatically, the first question is, how can we implement these innovations, is my question. As 2030 is tomorrow, we need to implement these innovations. And I'm going to start with the end user. Sven, can you elaborate? How could we do that hello. From the end customer perspective, please?
From the end customer perspective, first of all, hello to everybody. I think it was a great event today. I enjoyed it, unfortunately, from home. Oh, I'm getting an echo here, but okay, trying it anyways.
We hear you well.
Okay. Well, again, it was a great event, great innovations. Thanks for that to everybody. But in order to come back to your question, Iffet, I think from my perspective as a transport buyer, at the end customer, let's say, there's two perspectives, actually. The one thing is that on our end, I think we need to think differently going forward in regards to how do we design our networks, how do we design our concepts in order to contribute to these technologies, right? Because today, you know, if you have a diesel tractor in front of a trailer, you can use it very flexible for all kinds of use cases. And I think we need to think differently, design our network differently. Also, more looking at getting more in multimodal transport, designing maybe a hub network, which contributes to that. And on the other hand, what's from my perspective very important is the last point we have heard about today, not the last, but the one before. It's in regards to regulations, right? Because I think that's the base that we need, the fundament that we need, that e-trailers, e-dollies, and EMS2 vehicle concepts, you know, get a standard, let's say, in regards to regulations and the possibility to use them, because that's you know, not the case today in many of the things we have seen. And I think this needs to be changed very, very soon.
Thank you, Sven. And then I switch to a supplier. Christian, are you ready for these innovations?
Yeah, I think we are ready for innovations. We developing for many of them for a certain period of time. We're working on e-trailer concepts and have presented them. We have tried on some public roads. But I would agree to the statement before. One of the key challenges what we see is that there are not enough rewards for the end customer investing in the technologies. Because we're measuring today the CO2 emissions from an OE perspective, but for example, aerodynamics of trailers, which are since a long time in the market, which can bring up to 6–8% of fuel saving, are not really rewarded. So the incentive for the fleet is quite a challenge to using it. So I think it would help a lot in using this in this way. Instead of forcing everybody to do it, which is always seen as a certain pain, just rewarding invest into the good technologies.
Thanks, Christian. So maybe I can ask Aura from the DG Move experience, past experience, any questions you would forward or comments that you could make to the industry?
Yes, sure. Thank you very much.
Thank you.
Can you hear me?
Yes.
Okay. As you know, the Weights and Dimensions Directive, which has been mentioned a few times, and some of you might know that it's in the pipeline to be revised soon, so by the end of next year. And we're now starting the process, and what we want to look is also into what has happened in the past, very much related to the last intervention. Because in 2015 it was already revised in order to allow the use of aerodynamic devices, the rear flaps, and also the elongated caps. And it's true that according to what's happening in the market, they haven't been taken by the industry, well, let's say by the operators, the users. So the first question that we want to ask and ask ourselves is what do you consider that have been the main barriers for this uptake, and what are the lessons learned? What should we think differently, especially since we are looking into new aerodynamic devices and actually complete bodies? Very impressive.
Thank you, Aura. Then I will direct this question to the manufacturers. Thomas, what would you say from the ACEA perspective?
Yes, thank you, and good afternoon. Thank you, Iffet, for passing this question on to me. I think there's no easy answer to this. Indeed, manufacturers have supported the revision of the 9653 a few years back, but I think the answer to your question is the world is complex. So it is not just about defining and revising the 9653 in this case, but it is also, and I think we have heard this in one of the previous presentations here, it is also if the regulator also changes, for example, revises the general safety directive and the and other regulations which affect the design of the vehicle, unless those are actually in place, in force, no manufacturer will take the risk of anticipating what is happening here. So the short answer is the world is complex, and it's implementing those innovations, bringing those innovations that have been presented here to the market, is not only about just changing one regulation, but it affects it's a number of other regulations that are affected as well. And coming back to what has been said before, I think the key issue here is collaboration, is providing incentives for operators to actually get incentivized for using these innovations. Manufacturers have a very strong regulation already in place, which forces us to bring down the CO2 emissions on a fleet level, and the incentives also. I mean, this requires a solid supportive framework that is available. And one last element here. I mean, this is we're talking about this on a European level, fair, and it's definitely a European issue. But a lot of this also has been, at least in the past, subject to national, sometimes even regional regulations. So fragmentation is an issue. And one element that has been mentioned in the last presentation here, intelligent access policy. I mean, if every local community and city does this differently, then we're in trouble.
Thomas, thank you very much for this answer. And that directly brings me to my second question, Ben. It's the speed of legislation and how we could speed the legislative framework to implement innovations. And this time again, from the end user perspective, Raluca, as the representative of Aero, what would you like to say about it?
First of all, I would like to say good afternoon to everybody. And thank you very much for the invitation. And this question actually can be very nicely linked to the first question because Thomas, he kindly mentioned some of the barriers, but from our perspective, one barrier was also the fact that the legislation has developed too slowly. Because we had the revision of the weights and dimensions legislation in 2015, but as Thomas rightly said, that was not enough. And it was not enough, not only because it was linked to other parallel pieces of legislation, but because the conditions were not set in the framework. So the framework left the conditions open and they were subject to implementing legislation. And it took a long time until those implementing rules were set in place. So if there is something to learn from the past is that there must be a better speed of the legislative process, because otherwise we have the concepts which are firmed up in a piece of legislation and then we develop the actual conditions over years and years and the benefit can be lost.
Good, thank you. Well then, I will direct my question to the regulatory expertise, and Ignacio, what do you say about it?
Good afternoon, thank you. Good afternoon all. Well, if we speak about speeding up the regulatory process, I think that the best possibility is for all the stakeholders to be in agreement. Normally, a regulation, if clearly shows benefits and all the interested parties agree that the new technologies are good, there's no opposition, the regulator can be very fast in this. We have heard about national regulations. National regulations will appear if there's no common global European. So if European regulation come fast because everyone is in agreement, therefore different nations or countries will not be obliged to develop national, say, individual solutions. And then we have two regulations. Some regulations make an item or solution mandatory. Some regulations make something possible or allow that. So if this is something is optional, a regulation that clearly allows beneficial systems should not be a problem. So the idea is to present to the regulators a joint approach where the benefits are clear and all the stakeholders, so manufacturers, regulators and users are in agreement. I think that this is the best way. Thank you.
Thank you. May I kindly ask from the European legislative framework, maybe you can also contribute to that, Eva?
Sure, with pleasure. Thank you very much. And actually, I could only echo Ignacio about the speed of legislation, which depends very much on the agreement of all stakeholders involved and all those who are actually, at the end, affected by this legislation, right? So this was, yeah, I want to echo this. But the question is also what type of legislation, how far this legislation should go, in particular at the EU level. But before I go to that, I just would like to share with you my one observation from this very fruitful and very educative and rich program today. Intermodality, interoperability, connectivity seem to be the three leading, driving concepts behind all innovative technologies or innovative solutions, which are based on digital technologies, communication technologies, automation, whatever. But here, perhaps I will sound a little bit controversial. These innovative technologies, innovative solutions are not being designed or deployed, tested and deployed in order to reach, you know, high-level political goals of whatever Green Deal or a smart and sustainable mobility strategy, but in order to solve actual transportation problems, such as pollution, such as congestion, such as road safety, and such as inefficient use of fleets, loading capacity like we've seen today, inefficient use of road infrastructure, inefficient use of the workforce, which is very important in the situation where we really have a shortage of drivers. So, of course, all these problems created the foundation for Green Deal objectives, for smart and sustainable mobility strategy, which set certain strategic framework for any action, regulatory, non-regulatory initiatives, which should help to address all these problems. Now, AEROFLEX shows that such a multidimensional, holistic approach can really bring benefits in terms of safety, in terms of improving environmental performance of transport vehicles, transport operations, in terms of traffic and congestion. Now, how to scale it up, right? You asked about legislation. So first, if we talk about legislation, we indeed need favorable regulatory framework, but we also need what was already mentioned here by Ignacio and by previous presenters. We also need public acceptance. We also need users' acceptance. Public acceptance is extremely important in the legislative process at the EU level. So it's really up to us, up to those who develop this innovative solutions, up to project promoters to really educate the public, to educate the politicians, because this really helps in the legislative process. And then I come back to this favorable regulatory framework, what it would mean. And again, I would like to say that it's not only about weights and dimensions. It's multidimensional, because it's not only about how big, how long, how heavy the vehicles could be in order to adapt to these innovative solutions. It's not only about road infrastructure, safety of tunnels, safety of bridges, but it's also about data accessibility. It's about data interoperability. It's about data security, because all these innovative solutions are really based on access and exchange of data. In this case, smart and sustainable, just last words, smart and sustainable mobility strategy really takes this and offers this multi-dimensional approach. Just to mention a few initiatives which are coming: 10T revision, ITS directive revision, let me have look at my notes, mobility data space, etc. And of course, the closest to this event and to the final outcomes of the AEROFLEX project is the revision of Weights and Dimensions Directive. But we are really at a very initial stage of designing this initiative, and we are at the stage of gathering the knowledge base. So thank you very much for inviting us to this event and giving the opportunity to participate in the exchange, because really it helps us to gather this knowledge which we need to design well this initiative.
Thank you very much, Iwa. I think the third and fourth questions will be very related to your answers. So my third question comes on the way to these EMS vehicles. How could we efficiently use them intermodal? So of course, this question goes to you, Eric, first, and then I will continue. Please.
Yes, thank you. How to improve this? I think we have already spoken several times this afternoon about this, but the step forward is first to manage the supply chain as a whole and not anymore as an addition of different services. That's really important. Then, when doing so, then we will merge the strengths of each stakeholder involved in the supply chain, and then when doing this, also have then a supply chain more efficient and also sustainable. That's the harder way, and use then the right vehicles, the right mode for each part of the supply chain. But once again, we have to think to manage the supply chain as a whole, and not anymore as an addition of services. Today we are speaking a lot about digital platform, about exchange of information between all the stakeholders involved in the supply chain. Then we have also to do the same when we are thinking about how to deliver the goods on the right place.
Thank you, Eric. Then I would like to ask the end customers again. Fernando Luis, how would the logistics benefit from these EMS vehicles?
Yeah, at the end, I want to strengthen what it has been said before. I think the answer is in my background. And looking into the system perspective, looking how these pieces can really be interconnected and working together. And I think this is one of the great success of AEROFLEX, because they have been looking how these technologies can really fit into more the user needs. And that's thank you for the AEROFLEX team to look into this perspective. And basically, the value of the modular systems has been already explained many times by AEROFLEX in many areas, including intermodality. And I think it's more to make it happen. And as it was said, it's not only regulation, it's also market conditions, it's getting the users engaged. Users are now putting very clear targets in emissions reduction. So transportation is starting to be looking in a different way. And these are triggers that can make this happen faster now than 5 years ago. But we need to make it happen, and we need to collaborate for that and look into the system. And that's also something I would say, that even if we keep saying the system from the Commission and everywhere, we always see in terms of funding or whatever, it's very model what we see, instead of trying to get this connected.
Thank you, Fernando. I would like to come back to Aura. I remember there are some topics that you would like to raise about EMS vehicles as well, Aura, please.
Thank you. Yes, going back to weights and dimensions, I'm afraid. This was surely one of the hot topics at the time of the last revision. So starting the debate in 2013, there was already quite a polarized also approach to EMS. And I would like to kind of launch two questions in a way. On the one side is the main elements that were, or the main arguments against the use of EMS at the time, and we were talking just about allowing one cross-border with EMS, and that was just not possible to achieve the agreement. So the main arguments were reasons of road safety, reasons of no cooperation with intermodality or reverse model shift, so we will take freight from rail mainly, as well as damage to the infrastructure. So my first question would be more of a practical, I mean, what has happened since this debate a few years ago from those who are actually using EMS, so not about testing, but more about real experience or real life experience. If these fears, if these arguments have been confirmed, or they have been countered, what is their experience about road safety, about intermodality, and about infrastructure? And on the other side, since we also are looking into, of course, the European Green Deal and the future revision of Weights and Dimensions Directive is looking very much into sustainability and more concretely into boosting the uptake of zero-emission vehicles. So my question would be, if EMS can be considered somehow as an incentive, if it can be a conditional requirement to be used in conjunction with zero-emission vehicles. I mean, how can, if there is any, I think that Fernando from Alice kind of like said something during his presentation, his previous presentation, how can EMS go into the direction of helping the introduction, the deployment of zero-emission vehicles? Of course, for long distance transport, we know that the technology is in the stage where it is. I mean, there are other barriers, but can this be helpful somehow?
Aura, thank you. Then I will direct this question to Luis, because there might be some practical examples. Then she might already give you some practical use examples of the EMS, and then we will continue from there. Please, Luis.
Thank you, Iffet. Yes, because in the Netherlands we have now 20 years of experience with the EMS vehicle, and we are a very urbanized country, highly used network by traffic. And we could say that it is a real success. it should be purely a replacement of road freight transport to road freight transport, and there should not be goods transferred from rail or inland shipping to the roads. But it's not what we see on the roads. What you see is that all supermarkets, for example, are driving with EMS vehicles, because they have from point to point rides with a lot of goods, volume, and so they do those point-to-point distribution with EMS vehicles. So it's also on short distances that they use EMS vehicles. We can only say, as a country, I'm from a road authority, so I have no interest in having high-capacity vehicles as such. I'm not from a transport company or whatever, but seeing it as a road authority, it really, well, there are less trucks on the road, and that is a benefit. So, yeah. And from the public acceptance, car drivers, car drivers, they don't see the difference between a normal tractor-trailer combination, or they don't recognize them driving on the streets.
Luis, maybe based on the time, can we combine it with the intelligent access policies? Because we have seen the good examples of Australia, Sweden. How can we also combine the intelligent access policies is the last question, actually.
Yes, we think it is a very promising concept, intelligent access. We need a better match between vehicle and road, because we have a lot of challenges as road authorities with aging infrastructure, etc. So if we can more dynamically control the access from the vehicles to the roads, then we can, well, let me say, there's a huge difference between inland shipping, what they know about the ships that are on the waterways. They know everything. Who is the owner? What is the cargo? What is the destination, etc. If we look at trucks, we don't know anything. They are black boxes. So I think for high-capacity vehicles, but also for dangerous goods and also for abnormal loads, it would be great to have more information about which vehicle is where and go from where to where. So, and it is a matter of cooperation, not of control. But I want to hand over to Marcel Otto, my colleague.
I have only 2 minutes for that. Thank you.
Go ahead.
Please.
Yes, good afternoon, everybody. I hope you hear me well. Yes, maybe adding to Loes. So as a road authority, we need to assess the road transport with exceptional weight or dimensions, and we don't have enough information to do so. So we need transparency in their performances on a lot of areas. So on road safety, on the impact on the infrastructure, on the environment. All these things are relevant for us to monitor the performance, and also to give new exemptions. For example, for the MS2. We need the information to give also new exemptions and to give trust. So and we want to use modern technologies, so data it's coming from vehicle systems that can deliver this information, and that's I think the way to go, and that's a bottom-up approach. So we use systems that are already in place with commercial parties, and we add some things or some information layer that's interesting for authorities. And it's we also should take care about supervision on things like overweighing, and this is an important topic that we really need some facts and figures. We cannot just trust on let's say what companies say they are moving. We really need to check this information. So these are some examples of how we think we can move forward.
Much for the contribution. As we have very limited time, just one sentence, Steve. How could we go to the world of transportation, to the zero emission? One final word, sentence.
Be ambitious. No.
Good.
Just if I can take maybe a couple of seconds. I mean, I think it's important to recognise that there is a strong interchange, and I particularly thank Loes and Thomas for their interaction with the AEROFLEX group, and indeed with the wider community. So CEDA is more than 30 national road authorities. And Thomas and Loes are leading our group, which is looking at a lot of these aspects. I mean, indeed, we funded some research ourselves. I think one thing, or a couple of things I would underline. Karel put up the perfect slide earlier on when it said safety first, because that is not only this year it is CEDA's top priority, but every year it's the top priority of every single road authority. You know, we make the point time and time again, if you go from member state to member state, often it's only the road authority which has the legal targets for improving road safety. You know, we have a really special role there. Of course, then there are other things we need to work on, and questions about reliability are becoming important, as are decarbonisation. But I really want to stress this aspect of road safety. And in that, I would say, you know, we've heard a lot already today about, you know, cost-benefit analysis and the improvement. I'm sorry, guys, business as usual is not an option, okay? The sector is going to change. We are aiming for vision zero, zero deaths, zero harm, zero congestion. I hate the word congestion, so let's call it 100% punctuality, and we're aiming for zero carbon. We have to do that. So I think Fernando made the point earlier. This is, you know, everything you've talked about today is brilliant, but it's not about making the sector cheaper. It's about providing the sector with the tools it needs to make that transition. Because if you don't, you're out of business, you're dead. It's as simple as that. So embrace these challenges. I would also say, and it's a bit strange for me, those of you who know me, twice in 2 weeks I followed Eva on a panel, and twice I've found myself having to agree with almost everything she said, which is very unusual for me to agree so much with the European Commission. But I do want to underline, you know, this is the question of driver perception, and I've written that down here. Perception is an absolute key issue. Absolutely. Everything. I mean, we talk about weights and dimensions. It's not all we know that. It's not the data. It is the perception. And so we need to work on that. And I would make the link with the driver shortage, actually. We have a perception problem that we have to change. Anyway, when I said about ambition, what I would really like to say is this doesn't go far enough. Because when we're talking about intelligent access policies, you guys are all important, and I love you. But heavy vehicles are not the only thing we need to change. You know, we are facing now connected and cooperative automated mobility. We already have issues around dangerous goods, abnormal goods. You know, we're looking at road safety. So this idea of the data sharing, the connected vehicles that we will have to have in the future, this will be everywhere in the sector. And so what I would say is join forces with those and link them up, because, you know, I do have a vision where intelligent access will go so far, you know, we will have, you know, all of these safety benefits, we will have decarbonisation, and we will have 100% punctuality.
Steve, thank you so much. I have 2 minutes to finalize it. Thank you to all the participants who used the time, and I appreciate the punctuality. What we hear, AEROFLEX project created a safe space for such different stakeholders to come together. It's time to come together. This is my takeaway, Ben.
Thank you very much.
Thank you. Thank you for this panel. Thank you.
Never give me 1 second, 1 sentence.
Thank you very much, too, for being here. And that was a real honor to have you all on the stage. And yeah, we take your messages very serious. And yeah, we will join forces, Steve. So now some people have to go. I hope the taxi is ready and safe journey. Thank you. Thank you. We keep in touch. Yes, okay. Thank you very much. Nu, just comes to the hoofdlessen. Yeah, this was quite an exciting half an hour. I think we touched on very important topics, and we are nearly coming to an end. Are all speakers still in the hall? Raise your hand. Where are the speakers? Can you come to the stage? Because I have here some microphones. Can we disinfect? Because before we do the wrap-up, I would like to forward some questions we have gathered during the day. I really would like to ask you, keep the answer short of the questions, because, yeah, some questions I know I can answer, but some questions I need some, yeah, expertise and specialists out of the group. The first question was, which raises during the day, coming from the live stream, if we are going to use these EMS vehicles, do we save some road space? I think I allow myself to answer this question because Henning from Fraunhofer and I, we did some calculations about that. And we see if you could use EMS2 vehicles on European roads, there where you use them, you can easily save 35% of the space needed. For the simple reason, you don't have the tractor unit, and you don't have the distance between the 50 meters. So you can simply answer this question. It brings you roughly 35% of road space. And I believe then having more space for other cars or having less space for infrastructure. Then we had the second question, that is that the why did we not look at optimizing the engine size in our project? I believe, Julius, you are the right one to answer that, but I think it was not the scope of the project, so maybe you can answer.
Yeah, the answer is easy. So we did look at that. We did simulations, which basically the result was it's not a big difference if you reduce the engine size because, yes, a smaller engine basically is less weight, less expensive, and in some operating points more efficient, but you have always situations on your route where you really need a lot of power, and if you request a lot of power from a smaller engine, it's normally less efficient than a big engine. So there is not a big deal in efficiency. It's a thing with costs, and for the demonstrator, the reason is very practical. So okay, if you would design or buy a vehicle, you could operate it with a smaller engine if you can really have a cheaper engine. For the demonstrator, it was not an option because we wanted to pull the vehicle in any cases also without the electric drives.
Thank you, Julius. And I would like to add to this, since we are working on the roadmap to zero, we also decided we should focus on zero-emission vehicles in the future, and then we don't talk anymore about developing new combustion engines. The next one was for our aerodynamics team. What is the relation between if we reduce drag points in the terms of aerodynamics, how can we translate that in a fuel efficient or energy efficient figure? Because we talked about so much percentage less drag, what does that mean for reduction of fuel or energy?
I can answer that when the microphone is working. So roughly for a tractor semi-trailer, if we reduce the aerodynamic drag by 3%, then that's roughly 1% in energy efficiency. If you look to the EMS1 combination, then the numbers would change slightly, but say roughly 4% is 1% in energy efficiency.
Okay, thank you for this very short answer. The next question was about this nice trailer from Vanek and also the Smiths Cargo Bull trailer. They have this movable roofs, and what is the height difference between the top and the lowered position?
Yeah, when we brought the trailer to the project, it was 70 centimeters at the back, 30 centimeters in the front, but we had to reduce it a bit because we need to make we changed the back side, so now it's 55 centimeters in the back.
Okay, thank you very much, Ton. The next question was about, we cannot use electric-driven vehicles yet in the UK if it is about EMS and about EMS2 vehicles. Obviously, the Rigid Owens wants to know what the situation is in, for instance, Scandinavia with their legislation at local point. Could they use then already electric-driven vehicles in Scandinavian if it is about EMS vehicles? I don't know who is representing Scandinavia. Maybe Eric, you can answer to that question. Is there a possibility? Because okay.
Okay. I'm not aware of any limitations. We don't use the 25% rules for the driving force, so we can still have a 4x2 electric vehicle driving an EMS.
I thought also that with this respect, there is no limitation in legislation. There is nobody saying you cannot use an electric-driven axle.
Absolutely not. And by the way, just to point out, also battery electric vehicles will be still very efficient to drive in EMS, so battery is not the end of the EMS.
Exactly. No. That's what our full we are fully convinced about that. So we will need EMS vehicles in the future also, even with battery electric or fuel cell electric. So there is no way to think if we are going that route, you don't need EMS. And on the contrary, EMS can help us.
Yes.
Thank you very much. The weight difference between a dolly and a smart power dolly, Henning, I think that's a ton. But don't tell the weight of our prototype, because then you are lost in your story. And we have, of course, used a very big battery for special purposes.
Yeah,
so,
a standard dolly is 1,500 kilos, and the e-dolly in the end was?
4.7.
4.7.
Okay, so we had a weight difference of 3,000 kilogram, but I would really add to that, we had 75 kilowatt hour battery, which is not needed if you use a e-dolly for standard yard operation. So this weight penalty of 3,000 kilogram is not really to be seen as a normal situation. So, and we have to add to that, if you can save one tractor unit, and a tractor unit easily weighs 8 ton, 9 ton, so your weight difference using an e-dolly instead of a tractor unit is always more than 5,000 kilogram. So these were the main questions which were received via the day. So thank you, speakers, for being very shortly here. Then we come to the wrap-up of the meeting. And I have asked Urs Gunzert from MEN to give a very short summary of the day. We will not dive again in all the technologies we have seen. We will compromise the day in a few words. And then I would like to close the meeting with some remarks. So Urs, maybe you can tell me how you have seen the day and what was really, the highlight.
Yeah, thanks to you, Ben. Good afternoon. My name is Urs Gunzert, and I've got the honor to conclude this today's great day in the name of MAN Truck and Bus as the company coordinating AEROFLEX. And it's really a great number of presentation demonstrations. It was really perfect to be here today. And as you asked me to wrap it up, I take the freedom to wrap it up through the eyes of a pre-developer, as I'm responsible for this at MAN. And that's why I'm looking how to get those technology as fast as possible in our vehicles. And I think it's not far future what we saw today. It's a really close future, and we can apply this really fast. And even if it's not as a total EMS system, but even all those things we saw today as single pillars are really strong pillars we can build on, and we can apply it directly and bring it to current vehicles. And as I said, as pre-developer, I'm always thinking about SAF vehicles, so electrified vehicles. How can we get it in there? And if you are talking about 30% of more efficiency, I avoid the word fuel efficiency, you can directly turn it around and say 30% more efficiency is 30% more range for electrified vehicles. And this is really important if you think about the weight and the cost of batteries we need in electrified vehicles, or even if you think about fuel cell vehicles, it's not that different. So it's really important to get this increase in range. And I picked out 4 topics. I would like to have a small view on it. The first things really impressive was the energy management about the distributed powertrains. And it's on the one hand the electrified dollies and trailer axles, those distributed powertrains is also coming up, in my opinion, inside one vehicle, because if you're thinking about e-axles, we will go to distributed powertrains inside even one chassis vehicle, for example. And on the other hand, there are in current market already, for example, cooling trailers using e-axles for recuperating, filling their own batteries to have the cooling aggregate working. So it's already now really important to have this communication systems, and therefore we need brand-independent communication systems that we can avoid those trailers from recuperating to the batteries while we are going up a steep hill at the same time. So there's already now things we can implement directly now and not far future. Then about the smart steerable dolly, if we are talking about electrified autonomous vehicles, if I think about a cabless tractor, it's nearly looking the same like an e-dolly. And so if you just change the physical drawbar to an electronic one, we have a step to ensemble project finalizing last week, and we can use platooning and have all the effects of EMS, and maybe the dolly can leave the highway 5 steps forward or things like that. And this is really a great lever, but anyway, in need of drivers, the EMS, like we saw today, is the lever we can really pull further than going to fully automatic drives. Then we saw a lot about aerodynamics and front end. This one is really interesting, in my opinion, because we can see it for regulation framework. It's a really good example, because we have two sides I would like to go on. The one is the IVD, the increased vehicle dimensions. This is an example where we got already the legislation, and it's coming to that we have this aerodynamic effects and benefits. But on the other hand, we heard the example today about the missing trailer effects in Vecto, and this is a thing we have to use somehow in legislations, and we can bring it in there, maybe with the same effects we had in IVD. And one cap we saw already with IBD a few weeks ago that is coming to market. So this one will revolutionary for the cap over engine design for trucks. The last thing, it's a really interesting field of smart loading units, physical internet, and multimodal transport. And this one is, I think, a thing where we really have seen interesting tools like this puzzle cargo volume detection and so on. And it's also about standards again, so it's not legislation topic, it's about standards to find together and to bring it into field and to use it, and also again through the eyes of the electric drive. It's again for the axle loads, if we are looking at electric driven vehicles, really interesting if we could save the level of payload while using, for example, the trailer axle load in a better way when the tractors become more heavy. And also this is a really big chance we can use there. Okay, so finally I just want to say some thanks. First I want to thank the complete team, whether visible today or somewhere in the background. And you did really a great job, and to bring all those exciting things to such a grade, especially in those times with Corona and everything, and we thought in between no one could work on it and how to go on. So this is really impressive how this worked out. And then for sure I want to thank to ZF and Christian Brenneke to host this location, and it's a really perfect location. It was okay, it's not his thing to have the weather, but also the weather was perfect and cooperating with this location, so it was really great to be here. And then I'd like to thank the team of UniResearch for all this organization and really admirable event, and especially Ben for pushing us in our time slots and with his moderations. So I really enjoyed to be here. Thanks a lot to all of you.
Good. Thank you very much, Urs. I think those were nice words to end a very interesting day. I don't have to add anything to that, because you thanked the people we wanted to thank. So rest me that, I thank you then. We are at the end of, I believe, an interesting day. I really would like to invite you to join us, to stay here a little bit more, to have something to drink, have something to eat. As I said already, there are 2 shuttles, one at 5:30 and one at 8:30. So people who have to leave early, they can take the first shuttle, and the people who want to join for some buffet food and soft drinks, no alcoholics, only soft drinks. Enjoy your stay here. Thank you very much for your presence and being here. Look forward to see you soon. And people at home, also thank you for visiting. I have understood that you have connect from all places from the world, I have understood. So even outside Europe, people were connecting. So it was quite an intercontinental day today. And I think we can be all proud on that. And thank you to you all being here. And let's enjoy now a little relaxation. Thank you very much. See you very soon.